Okay, Rishita has also joined. So Rishita, can you hear me?
Yes, sir.
Okay. So let us start. Today's topic is geometric progression. In the last class, we did arithmetic progression. So today we will do geometric progression. First, we will recap some important points regarding geometric progression. So what are those important points? Like we have uh, A1, A2, A3, so on. It is a series or sequence, whatever you can tell here. And it is called geometric progression. It is a GP. So in AP, we studied that the difference is common. A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3. So there is a common difference in AP. In JP, we don't take the difference, we take the ratio. That is A2 by A1, A3 by A2, A4 by A3. So the ratio of consecutive terms is same, which is constant. And this is denoted by small r, which is called common ratio. Like if we take a simple example, we have 3, 6, 12, 24, 48, so on. So if we take the ratio here, like 6 by 3, like 12 by 6, like 24 by 12, like 48 by 24. So you can say that all of them are same. And what is that value?
2.
2. So the common ratio is 2 here. So this is what GP means, that the consecutive terms have the same common ratio and it is denoted by small r. As in AP, there is a common difference which is denoted by small d. Now, if you take the first term as A, suppose, the next term will be AR. I will let you write above part also. First, let me tell you this. So if first term is A, next term will be AR. That is, if first term is 3, next term is 3 into 2, right? Because 2 is the common ratio here. After that, AR square. That is what it means, 3 into 2 square. That will become 12. Then AR cube. That is 3 into 2 to the power 3. That is 24. Like this. Now, if you come to the nth term, you keep on writing them. And when you come to the nth term, that is AR to the power n minus 1. So this is the nth term of a GP. So this is how a GP can be written with the help of the first term and common ratio. In AP, what we used to do, if we would have this as a GP, instead of that, we used to take AP. What we used to do, A, then A plus D, then A plus 2D, then A plus 3D. So there was addition and D was getting increased. And A plus N minus 1D was the nth term of an AP. So similarly, you can see that what is happening in GP, there is multiplication. So you can now write it down from here.
Finish, sir.
Okay.
Finish, sir.
Okay. So if you see here, we are now taking sum of n terms of a GP. So I'm not going into the derivation of the formula. I'll just tell you the formula because that is what you have to generally use. So AR square, AR cube till AR to the power n minus 1 is the nth term. So if you add them up, A plus AR square plus AR cube, so on till AR to the power n minus 1. So this sum is A into 1 minus R to the power n by 1 minus R. So this is the sum of n terms formula. This formula is there, sum of n terms. Suppose we took an example above that it is 3, 6, 12, 24, 48 like this. This is a GP. Now someone asks you that what is the sum till 20 terms? S, generally we write it like this, S20. That means sum till 20 terms. So what is A here? A is 3. And what is common ratio? Common ratio is 2 to the power 20. So we'll write it like this, that it is 1 minus 2 to the power 20 upon 1 minus 2. So this will be 3 into 2 to the power 20 minus 1. Because denominator will be minus 1 and that minus 1 can be taken in the numerator. Now you need not find 2 to the power 20, but it will be a very huge number. You will write it like this only. So this is the answer. This is sum till 20 terms of this GP. This is how you write it. So start writing from here. This you can even write it like this, Sn. That means sum of n terms.
Done, sir.
Okay.
Finish, sir.
Okay. Now one more thing is here, which is not in AP. In AP, we studied what is nth term, what is sum till nth term. Similarly, in GP, we have studied what is nth term, sum till nth term. One more thing is there in GP, which is not in AP. That is if the common ratio is between 1 and minus 1. Okay, if the common ratio is between 1 and minus 1. then we can find sum till infinity of a GP. This is not possible in AP. In GP also, if common ratio is greater than 1, then sum till infinity cannot be obtained. It is only obtained if it is between 1 and -1. For example, 3 is there, and then there is 3 by 2, then there is 3 by 4, 3 by 8, 3 by 16, so on. So if you see this series, in this series, the common ratio is half. If you divide the second term by the first term, you will get half. Or you divide the third term by second term, you will get half. So if you go till infinity, you can find its sum because this value will keep on decreasing and after some time its contribution will be 0. So sum till infinity can be found out from this series. So what is the formula for that? Sum till infinity, A upon 1 minus R. Okay. So you have to just remember this formula. Again, we are not going into the derivation of it because it involves the concept of limit. So we just need to know the formula right now. So here if we apply in this example, this formula, so A is 3, 1 minus R is half. So 3 by half it will become, which is equal to 6. So sum till infinity is actually 6. So this will be our. Here you can see that common ratio, which is half, is between 1 and -1. Then
Minus
only we
1.
can apply this.
Correct, sir.
So let us discuss few questions now. So this is a question here. It says Ram gives his son rupees 100 on one day, rupees 50 on the second day, rupees 25 on third day, and so on. What will be total amount given by Ram to his son starting from the first day if he lives forever? Suppose that Ram lives forever and he is giving every day some amount to his son. He has started the first day rupees 100, second day rupees 50, and keep on doing half of that. And suppose Ram is living forever. So what will be the total amount that he will give to his son? Just try this. Generally, forever means like if someone lives for 60 years or 70 years, so the number of days will be like 365 into like around 30,000, 40,000 days. So that can be understood as a very, very large value. We can call that infinity because infinity, ka jo practical, what it means, infinity, it means a very, very large value. So in this context, even if it is not written that he lives forever, even living for 30,000 days or 40,000 days is enough to consider that it is a sequence of infinite terms. So what is the sequence? Can you tell the sequence?
Sir, 100, 50, 25, so on.
After 25, what it would be?
After 25. 14.5.
12.5.
Yes, sir.
Because it is getting half, right?
Yes, sir.
So what you can say common ratio is?
50.
No, it is 50 by 100.
Sorry, 2.
1 by 2. Okay. Or you can say 25 by 50. That is also 1 by 2. Any two consecutive term next divided by the first. The value which is next divided by the value which is previous. So common ratio is half and you have to find sum till infinity. So what is the formula? A by 1 minus R. What is A here? The first
100.
term, that is 100. Okay. And what is the common ratio?
1 minus half.
This will be 100. 1 minus half will be half. So it is 200. So here is simply 200 is your answer. So as we did in above example, the first term was 3. Here it is 100. Rest common ratio is same. Okay.
Yes, sir.
Just try this question. So this question says that the third and the eighth term of a GP are 4 and 128. Find the GP. So what is the mathematical equation for this?
That should be right. A plus 2D.
So it is a GP, it is not an AP.
So A plus R cube. Sorry, A into R cube.
For third term, it will be A into R cube or A into R square.
AR square. AR square.
So it will be AR square. Also, you can remember that nth term formula is AR to the power n minus 1. So if you want to find A3, so it will be AR to the power 3 minus 1. That is AR square. So AR square is given as 4. And another one,
Sir, 8 R 7.
AR to the power 7. And it is equal to 120. So these two equations you have. Now what you will do?
So can we substitute them?
How?
A AR square brackets AR raised to 5 equals to 128. So AR square we know 4. Can we do that?
Uh, what exactly you have to do here is simply you can divide the second equation by the first equation. If you will do this, then what will happen? AR to the power 7 by AR square is equal to 128 by 4. And you can see that A will get cancelled and R to the power 5 will remain. 7 minus 2 is 5. Is it okay?
Yes, sir.
And here it will be 32. And 32 is actually 2 to the power 5. So what we got is R to the power 5 is equal to 2 to the power 5, means common ratio is equal to 2. Now after getting common ratio is equal to 2, we will see any one equation, suppose this one. So A into R square, that is 2 square, is equal to 4. So here A is equal to 4 by 4, which is 1. So A is 1. So if you want to write the GP now, so GP will be starting from A, that is 1, AR 2, AR square 4, then 8, then 16, so on. This will be the GP. 1, 2, 4, 8, 16. So if we see the option number B will give you the correct answer.
Finish, sir.
So let us come to one more question. Which term of the GP 6 minus 12, 24, minus 48, so on is 384? Just give it a try.
So over here the like 6 to minus 12 is minus 2 and minus 12 to 24 is so the ratio is minus 2, right?
Yeah, ratio
Like
will be minus 2. Because if you take minus 12 by 6, you will get minus 2. Or you can take 24 by minus 12, then you will also get minus 2. Likewise. So common ratio is minus 2, correct? And the first term is 6.
answer is the answer 6.
Answer is 6. Okay. So it is a r to the power n minus 1 is equal to 384. So a is 6, r is minus 2 to the power n minus 1 is 384. Now, which means minus 2 to the power n minus 1 is equal to 384 by 6, which will be 64. So minus 2 to the power n minus 1 is equal to 64. And 64 is actually 2 to the power 6. So even you can write it as minus 2 to the power 6. Okay, even power is there. So minus to the power even is also plus. So therefore, minus 2 to the power n minus 1 is equal to minus 2 to the power 6, which means n minus 1 equal to 6. So n will be 7, not 6. It will be 6 plus 1, which will be 7. So answer will be B option. This is the nth term, ar to the power n minus 1, which is 384. And we have to find out which term is it. Is it okay?
Yes, sir.
Please write it down.
Finish, sir.
Okay. Try this question. Find the sum of GP 1, 2, 4, 8, so on up to the 10th term. The first term is 1. And what is the common ratio?
2.
2, correct? So you have to find sum till 10th term. So when you put it the formula, what you will get?
Sir, it is A, so 1,
Yeah, correct. So actually it is A, which is 1 minus R to the power n by 1 minus R. This was the formula. So this will become 1 minus 2 to the power 10 and it will become minus 10. So if you take minus 1 above, it will be 2 to the power 10 minus 1. So option A will be our answer.
okay, sir. Finish, sir.
Let's try this one.
Sir, I'm getting 9 by 2.
9 by 2. Okay. So how you approach this question? Can you tell?
Sir, I wrote A is equal to 3.
Okay.
Then R is equal to 1 by 3.
Okay.
Then S infinite is equal to A by 1 by R.
A, which is 3 by 1 minus R, which is 1 by 2. Okay.
3 by 2 by 3.
Yeah, correct.
Then 9 by 2 I got.
Yeah, fine. So the option will be our answer. Try this one. How many terms of the following GP has the sum 127 half?
Not getting, sir.
Okay. Rishita, what about you? What you are not get,
Sir, I'm getting it 2 minutes.
you are getting?
I think, sir, 2 minutes.
Okay. So let us see how many terms of the GP 64, 32, 16 has the sum 127 half. So 127 half can be written as in mixed number 254 plus 1, 255 by 2. So in this way we write it. Now what is the first term? It is 64, and what is the common ratio? It is 1 by 2, right? There is no doubt about it.
Yes, sir.
Now we take how many terms give you this addition. So sum till n terms suppose give you this addition. So sum till n terms means A, which is 64, 1 minus R, which is 1 by 2 to the power n, by 1 minus R, which is 1 by 2. So this is the formula sum till n terms. We apply it here. And it is given that this is equal to 255 by 2. This is given in the question. So what we will do now is we will write it as 64, and 1 minus half is half, and this is 1 minus 1 by 2 to the power n, and this is 255 by 2. In the next step, 2 will go in the numerator, so it will become 128. 1 minus 1 by 2 to the power n is equal to 255 by 2, it will become, right? In the next step, we will take 128 in the denominator of the right hand side. So it will become 255 upon 128 into 2 is 256. So this will become 1 by 2 to the power n is equal to, if you take it on one side, 1 minus 255 by 256. Now, if you take LCM, it will become 1 by 256. So what we get here is 1 by 2 to the power n is equal to 1 by 256, which means 2 to the power n is 256, taking reciprocal both the sides. 256 is actually 2 to the power 8. So you will get n is equal to 8. This will be your answer. So 8 terms will add up to give you this answer. So you will say the option is 8. Now you can write it down.
Finished, sir.
Okay.
Finished, sir.
Okay. So let us see the next question. This is the next question. Find the sum up to n terms of the sequence, and the sequence is 0.7, then 0.77, then 0.777, and so on. Sum up to n terms. So right now it is not a GP. You will have to do some changes to make it a GP. So think in that direction. So let me give you some starting hint. So you have to find the sum of this 0.7 plus 0.77 and then 0.777 up to n terms. So what you will do first, you will take 7 common. So it will become 0.1. It will become 0.11. It will become 0.111 and so on up to n terms. Okay, we can write it like this. Still, it is not a GP. So what we will do, we will divide by 9 and multiply by 9. So it will become 0.9. It will become 0.99. It will become 0.999 and so on up to n terms. Still, it is not a GP. Now, one last thing we will do. Till here, everything is fine. 0.9
Yes.
can be written as 1 minus 0.1. 0.99 can be written as 1 minus 0.01. 0.999 can be written as 1 minus 0.001. And similarly up to n terms. We write it like this. Now, we can see that if we collect all the ones, one will be from here, then here, up to n terms. So we'll get n minus, then we have 0.1 plus 0.01 plus 0.001 up to n terms. Now this series 0.1, 0.01, 0.001, this is a geometric progression with the first term 0.1. This is a GP. With the first term 0.1 and common ratio is also 0.1, because if you multiply 0.1 to 0.1, you will get 0.01. Then again you will multiply 0.1 to this, you will get 0.001. So you will therefore get the formula A, which is 0.1, 1 minus r to the power n, that is 0.1 to the power n, by 1 minus 0.1, that is 1 minus r. This formula you will get. So 7 by 9 n minus, this will become 0.1 by 0.9, and this will become 1 minus 0.1 to the power n. Now little bit of calculation we have to do. So this will become 7 by 9 n minus, this will become 1 by 9. So 1 minus 0.1 to the power n by 9. So if we see the option, okay, and it is 10 to the power. Okay. So we can write like 9 we can take outside after LCM. It will become 81. And this will be 9n minus 1 minus 0.1 to the power n. And this will be 7 by 81. 9n minus 1 plus 0.1 to the power n if you open the bracket. I will let you write all of those things. First, let us complete it. 9n minus 1. 0.1 is 10 to the power minus 1. 0.1 is 10 to the power minus 1. That is 1 by 10. So you can write it as 10 to the power minus n. Now let us see 7 by 81, 9n minus 1, 10 to the power minus n, which is option B is our answer. Now you can write it down. And similar type of questions you have to approach in this manner. Is it clear to both of you?
Yes, sir. Finish, sir.
Okay.
Finish, sir.
Okay.